All right, here's what I came up with. I fell asleep earlier for a few hours. Um, I was just kind of chilling watching Dr. Phil's show. I like Adam Ray. I was watching that. Um, but I started putting some of this stuff together and I was starting to feel kind of tired, but I was making some good progress. Essentially, what I built was a schematic based off of this matrix. And this first part here is the XOR, the primary XOR. So this is your inverter right here. And then this is the A and B design of the XOR. As you can see, the CN completely bypasses it. It goes to the second XOR. But the thing is I'm not really sure what to call this because I don't think it's an exclusive NOR, but it's not the and the ORs. It's not that at all because you can see it's essentially a 10 transistor design, but I had 15 transistors in that design. So as I'm going through the list and I'm starting to piece things together, I'm starting to see it come together. And I guess I forgot to label this part. There's the A, B, and C is right here. So this is your, um, where is it at? It's this output right here. It's A plus B plus C. I don't really have a way of doing the circle with the plus symbol, so it's right here. See, your A and B comes in on this side, and your C in is, I thought it was coming in right here. Yeah, right here. So the C in, and then the A and B. The A and B I have actually coming in over here. Did I swap them? This part of it's kind of a little weird for me because I started building it, and then as I went down the list, the O negative goes over to here to this X2, N2. So this is kind of like I was thinking that this was my XOR2. And then I'm like, no, I don't know what this thing's really turning out to be because I started eliminating shit and then I didn't really know what to name the transistors because it's like some of these guys are gone. Some of this is not the same trace. Like it started becoming something different. Overall, it's definitely more streamlined. Um, I'd seen a design. Okay, I haven't seen it. I've seen a picture of an adder, but I couldn't really tell where the hell any of this stuff um, connected. I don't have a schematic for it. All I have is an idea of how it was laid out. But I essentially tried to keep that somewhat the same as I built it so that when I got down to this last little bit, um, I was able to see at least some of the stuff with like the rails. Like, okay, it looked like these rails were connected. So I was like, all right, so that's basically part of this, what was the other XOR. But the thing is I don't know if I would call this the XOR. I mean, this could be X2. I mean, this could be X2 P2, but I don't think so. But as I was laying out the traces, I'm like, well, this one is acting like it's the X2 P3 that was here somewhere, this guy. So I labeled it as such when I saw it kind of connecting the way I have it in my matrix here. But at the end of it all, it's this part I was having a little bit of problems with right here. And I think that was not only my A plus B plus C, but there was the B times C, the A times C, and the A times B that part, I'm not 100% on the flow of how that worked, because that was supposed to be the two AND gates to the OR gate. And I was explaining earlier, I'm like, I really think I can condense all of this stuff into one format, like a 3-input, 2-output um, exclusive OR gate of some kind. So maybe that's what this is. Maybe this is a 2-input XOR right here, cutting off right where the power and ground is. So maybe this is a 2-input XOR, and this is a 3-input XOR. Maybe, but I don't think so. Because I hadn't found any kind of schematic online or anything to kind of somewhat follow. I just kind of slapped this together and used some of the what I saw in the screenshot of a 16 of the adder, the full bit adder on Steam, and I just kind of, some of the stuff that was left over. I mean, I can tell. Okay, all this is doing is coming off of this, and it's doing that. So I try to label it as best as I can, but again, I'm not 100% on this part. So I do want to understand that, so that if I need to implement it later, I at least know, yeah, that's what this was. This was a 3-input exclusive OR gate or something like that. So I think that's what this is, but I'm not 100% sure. But the thing works. So since I'm awake and I'm not sleeping, let me see if this will help me go back to sleep. So, but I had done most of this earlier, but I was falling asleep doing it while I was doing the that Adam Ray show and something else, maybe a podcast or something. I don't remember because I was falling asleep. But I got a few hours of sleep, and I don't know what woke me up, but let's get this going. So let me see if I can implement this in the game, and then maybe we'll start streamlining that. But probably by the time I'm done making it, I'll probably be ready to go back and get a little bit more sleep. But I'm pretty sure this will be it. Like, I don't know what else I would do. I would probably have to build another matrix, verify it, and see if there's any way to condense it even more. I'm not sure, but one step at a time. Let's go with what works. So as I was saying earlier, I'm seeing where I have these inputs here to this lower half for the carry out, because it's not like I have anything going here and coming back to go to the sum. Essentially, this is taking care of the sum, and this is taking care of the carry out. And I feel like I'm going to sneeze. I was definitely suspicious that I can get, suspicious, I guess you could say. I was definitely feeling like I can get rid of these inverters right away and just use the other ones or other outputs to feed gates that I needed to make this circuit work. So, but instead of eliminating one thing at a time, I feel like I do have an actual working design. So I don't need to eliminate one thing at a time. But like you can see, I don't know, I just feel like I can just wasn't really using all this stuff. I need to move it to the screen. Let's move this over here. And we'll move this guy over here. Stop doing that to my work. Okay, that's good. That is there. So the thing that I call a matrix that I built on Google Sheets, it's a similar concept to when I build my fiber routes and whatnot. And you can do it in other instances of networks, but the main reason I would really use it is for fiber routes. And I'm talking stuff that can go dozens of miles, if not even 100 or plus miles. Um, but I don't go that far. Most of my stuff is only a dozen or so miles. I think one of my furthest links that I work on is upwards of 300,000 feet, um, or 100 kilometers. I think that's the furthest that stuff can go. Although it's not, sorry, it doesn't go 100 kilometers, because that's, I know some of our transmitters are capable of doing that, but we don't ever push them that far. So I would say my furthest one is probably two-thirds of that, probably more like 60 kilometers, maybe 70, somewhere around that range. Um, but the fiber doesn't go straight from our source to the end, just straight there. There's splices in between, because you can't buy a reel of fiber that has 80 kilometers of, you'd be talking a reel of fiber that would be what, 100 feet tall or something stupid like that. um, I don't even know exactly how tall it would be, but it'd be pretty big, and logistically not feasible to ship to a customer. So typically our reels of fiber are around 24,000 feet, somewhere around there is pretty common. That's more, we're able to carry it on a trailer. We're able to move it. Um, and so you're talking at a minimum of, if you just used for that longest link that I mentioned, that was about 300,000 feet, you know, at that point, you're talking about a minimum of 12 reels. However, because of the way the roads are and the way things move, and you're following pole lines, and it's not, some of it's underground, some of it's aerial, it's doing all sorts of stuff. There's going to be other reasons why you wouldn't be able to fully use the 24,000 feet of the fiber. You're probably having to do a splice sooner than you really would want to, because sometimes it's just the way it is. So I would say it's pretty average to have roughly a splice can for the fiber every most likely 8,000 feet. And again, there's certain instances where there's several within the 8,000 feet, or you can probably pull off. Maybe you have a long stretch through some woods or something, or maybe along a highway that doesn't have a lot of offshoots. Then maybe you are pulling that fiber quite a ways before you splice it. Um, but in any event, there's going to be reasons that you're going to deviate from your main backbone, and you're going to have splices for that. And so, definitely pretty common to have um, at least one or two cans every 8,000 feet or so, depending on the design. So, with that being said, you would have something like this that would show all the splices and where you go from one can to the next, how it goes. And, if you're smart, you're going to do one for one. You're going to keep all of your fibers the same color in the same bundle. But of course, that doesn't always happen. So, and sometimes you have different size count fibers going to different cities, going to different places. So that's where you're going to branch off, and you're going to take fiber from one tube and transfer it over to another colored tube. And so you have to show that in the matrix. You have to say, hey, this blue tube of fiber, every fiber we transferred over to this orange tube, because we're going south now, and we went from east, now we're going south, and we just moved it over to a different tube. That's just an example. In my fiber to the home designs, I typically would work it backwards actually. So a quick example of that is your blue tube is your primary tube, and I actually would make that the end of the line tube. So I would want it straight spliced all the way till the end of a line in some neighborhood or wherever it's going. If I'm transferring from, let's say, like a 96 count fiber over to a 24, I'm trying to keep that stuff somewhat uniform. So I'm going to branch off a couple of tubes of fiber to that 24. They're going to be blue and orange. Well, I'm going to try and make that blue tube go down the long stretch of that street, and the orange tube would branch off to the earlier, maybe there's a street that branches off of that. I would have that on that orange tube. So the blue would go further down. Um, that way, if you're looking at it from a matrix perspective, all of your splices will stay the same essentially. Otherwise, you're going from blue tube to orange back to blue, and you're doing stupid stuff like that. And I've seen people do that, and it's dumb. If you can try and keep things uniform, then it would make sense. So that is why I can kind of feel comfortable messing around with Google Sheets and doing this coloring coding scheme and trying to follow these traces, because it's similar to like a fiber trace in a way. It's not the same, but it's similar. So that being said, I think I should just scrap this design, because I don't need to really. This whole part right here is essentially being completely obliterated to the point where I think I'm only using like 4 transistors or something from it, as far as I can tell. That's the part I'm kind of struggling with, what's going on in my new design. Um, so maybe I'll figure it out tomorrow or something. I don't know, but I know this guy still pretty much stays intact, and the second one, for the most part, um, is just about all there too. And I see where the CN plays a major role, and you can see where it bypasses the XOR1 and it's in the XOR2. The CN is in this guy, and it's in the AND gate too. Um, so that's why I was like, what really is the second half of my design? Is it an AND gate, an OR gate, an XOR gate? I think it's a 3-input XOR gate, I believe. Um, but whatever it is, I believe I got it working. So let's go ahead and get this going and see if I stay awake for it. So to keep things simple, I think I'm going to not get too crazy with this. As much as I want to put the XOR out there, I think I'm just going to follow the schematic. I kind of like it where all of these positive transistors are up top. And I don't know if I'm really going to do. I'm sure I'm going to scrunch these together. I probably should, but I think in order to verify that this stuff works, I might just do this for now, and then I'll consolidate it. Yeah, let's just make it work. So I'm going to space it out like that so I know which groups I'm in. So this is group 1. This is the XOR1. This is group 2, which is the transmission gate for the power and the ground, but the left side of it is XOR1. The right side of it is, I guess, XOR 2, but I'm not going to act like I'm sure and I know 100% what it is. I'm going to leave some space in the middle for my rails because I do have a lot of stuff that's going to be going left to right. So let's leave that. And in fact, let me go. I'm going to probably do 2 sets here. 1, 2. So let's do something like this. Let's do a 5 wide. So this is similar to a what you call it, a design that I'd seen, but I couldn't tell how I was hooked up. But now that I see it, I know it's going to make it easier for me to make it flow, and then I can start to actually condense it, and I could probably make it look like another one that I saw that, again, I don't have a schematic for, but I can kind of see where it was going up and over, but I just don't know where everything was going. So it's one of those things you kind of know it's possible. You just don't know why it was working. So I would imagine somebody probably saw the flat design and then condensed it like I'm talking about and came up with the more compact design. Either way, I want to do it too, and I want to see it. I don't want to just blindly copy people's shit. So I'm kind of using it as a guide for I'm seeing something, and then maybe I need a little extra, maybe something I'm not seeing that's right that I need help with. So I do want this carry to be here. I want these guys here. But I need those to connect. We'll see. Let's just get it going. All right, so you have an A here and an A here. And then you have A here. And you have A here. Now, I may switch that to aerial depending on what's going on. This carry-in is probably going to be aerial the whole way because it doesn't connect until over here somewhere. So in fact, I'll probably just, he's going to probably be down there somewhere. All right, B. That's B. That guy can get over that, so that's fine. This needs to go there, so I'm going to do that. Move that there. Okay, we got A connected. B, I still want to continue on, so let's do this. It's kind of roller coastering here, so B, it's going to come from here. We may or may not keep it like that. I'm going to go ahead and do C in. At a minimum, it needs to be that tall. I'm probably going to go taller with it. I just want to get some of this stuff connected. This guy is separate. It's going to connect those two anyways. And then that to there. Okay. That. Is this the same? Our AB out is this. So I'll just do that. The AB out goes there, goes up there. So we'll stick with top. That's going to touch. I will go ahead, since AB is only going to be feeding those rails. Oh, it does go down too. Okay. It's going to be the rails for these guys. So let's do this. That's AB, which is my XOR 1 output. See how they're combined. These are the outs. These are the outs. So I will most likely mush those guys together, because the only rails that are shared are these rails here. So I think it'll be more beneficial to mush them east and west, because the north and south for these guys, that won't work. I think that's how I would handle that. But again, I just want to verify the thing works first. So there's the rails there. It continues on to the rail for that guy as well. So let's continue on. So it is also the rail for this guy. And it is also the input for this guy. Okay. Let's go ahead and bring that out just so we can get this going. It's probably going to be something like that. Okay, that guy's good. And then we need to go south here to feed the rails for that. Okay, so we're going to go over here. It's going to be that rail. And it's the gate for this side of the inverter. All right, so that is all AB. This tall guy right here is all AB. which is the XOR 1 out, combined out. All right, this is where I start getting a little off the rails here. So let me work left to right. So I'm still working off of my XOR 1. Here's the inverter right here, the power side and the negative side. So the power, that's where there's going to be a problem. I need to be able to raise up and do the power. So I at a minimum need to have more clearance here so that this guy, so what I can do is I can bring him back and bring him up. Okay. I think I'm going to have the same problem with this guy. Let's verify. Does that touch? No, we're actually good there. Okay. Combined input for there. Okay. And combined output is going to go over to these guys here. So we can't do that. We have to go up for both of them. So maybe what I'll do is just simply bring this guy over. That touches, that touches. It touches, and then that, no, that doesn't touch. So how can we make this work? That's going to touch. We need this guy to get over to there, to this rail. So I may have to do some funny business. I was really trying to not do things this way. If I simply move the carry in all the way to the corner, I can come out below. And then I'll just bring it over. I'll keep it underneath the negative rail and switch it. Switch it somewhere around here. This guy can go aerial. And in that way, that guy can go underneath and feed there. So now they're combined. This guy will go up. over. He's going to be touching that guy, but I will move it. See, because now this guy can be lower. Okay. So the carry in is there, and I'll probably make that carry in taller, although it might touch that one there, but we'll finagle it how we need to. Next is this inverter here in group 2. We have the rail already hooked up. We need the outputs tied together is what we need. So this guy, if I could, I would keep it on the ground. But it's going to have to go like that. Those outputs are tied together. The input of A1 and 3 is from the CN. That's right above me right here. Okay, that's a done deal. This is much easier to hook up, doing things this way, and then verifying it works, making sure I got it right, and then I can start implementing a much more efficient design. So we're in group 3, A1P3. Whether or not that's the right name for it, it's a name. But I got the inputs already. I need the outputs to go across. That's for the C out. And both of these are tied together that are going to be C out. So since that's the case, I'm going to keep this guy up this way and get rid of the groundwork for simplicity reasons. Can I turn it? It's touching right there. Yeah. I can go there and be good. And then this will be, this was C out, right? From the group 2. Yeah. Kind of wanted the sum to be there, but I'm going to have to. Why don't I just bring it up and over here? Let's just do that. Because that should be all for C out. There shouldn't be anything else that ties into it. C out is strictly from this third group here. So my rail is coming from, those rails are tied together, which is tied to the inverter. Okay. So this should hopefully be easy. The inverters combined. go like this. Boom. I have it drawn from the south side, but it's going to be the same from the north. It's the same thing. However, that inverter does continue on, but I got this big fucking rail in the way. So this combined output, along with this one, that's your sum, that's your output for your sum. And then these guys are tied to that inverter line I just did. So I think the easiest way I can do that, instead of having to fight this stuff, I mean, I might be able to make it work. I got that guy in the way. Can I do something different with him? I mean, I can lower it. Yeah, it's going to lose it here. Either way, I'm still going to need to connect there, and that's going to be in the way. So I actually am better off going above. Let's keep that connected so I don't forget. Let's do this. Those are connected, and then I need to let's take this rail. And where did that need to go again? It needs to go here, right? Yeah, because it's in combined inverter output goes to these two rails here, comes over to this rail, and goes over to that input. All right. Let's see if we screwed this up. Just validate it, right? All right, well, first try, right? Okay. So it looks like the advanced blocks is going to be in the 350 range, maybe 360. Volume would be probably somewhere around, what is that, 1600, 1800 range. The ticks are going to be around 360 to 400 range. And the best transistors is 16, which is what I just did. So save that blueprint. Was something shorting out there? Am I crazy that I saw a short? Well, that worked on the first try, which I guess I got to hand it to this. The Logisim software worked, and that was nice because I didn't want to do all of this drawing and jumping up and over, and then this isn't right or that. I feel like doing two-dimensional was easier because I started just literally connect, 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 connect. I just followed my matrix. And again, where I started running into some trouble was right around here, because I was noticing that the outputs and the inputs were different. And so I was like, well, if this guy goes here and goes there, I think that's the X2. I think that's this one. So I kind of built this bottom and got that going. And then it was from there. Again, I was like, it was right around here. I was kind of like not sure what to do. It was really like this third group. I was kind of lost. So I looked at this picture, not not this one. I looked at another one where I was like, all right, this is more of a flatter kind of design, and I was like, yeah, I can see, I can kind of see where these were connected, but I couldn't see what else was going on with this pass through. So I was like, man, I don't know. So, but with a little help, I think I figured it out, and now it's a matter of consolidating it. So the way I did this matrix to try and explain this a little further, I did color code the similar the ones that were in common, so I could see what was in common. I could see that there was about 12 groups of 12 groups. There was like 12 transistors that I needed for these traces, but I still needed two inverters, so that's another four, um, to continue on with the design. So um, and some of it again was in one of the inverters right here, this guy. So the next thing I did was, obviously I did the paths where we had the gateways, the gates. And then once I got those going and I saw this kind of pattern with the C in, this zigzag pattern here, and then the X1 outs, I was like, oh yeah, there's something here that I can work with. But what I did is I reversed it. So instead of working from left to right, I worked it from right to left. And you can see I reversed it up here. And then I took and copied each row. And I'm sure there's a way to, in Google Sheets, to do it the way that I did, but I just did it manually. I didn't want to have to fight it and fix it. So, are you waking up?
Yeah.
You don't have to wake up for school.
Yeah.
I'm explaining my matrix thing that I came up with for my program that I was working on.
Yeah.
So I figured this stuff out. I figured out most of it. Some part I kind of didn't really understand, so I got a little bit of help from a screenshot that I looked at that helped as well. But you can see where I can see the patterns and color coding, and then once I started kind of putting it in that order, see, I ignored these orders and I just went with, okay, what is in common here? And once I did all that, I transposed what I saw onto this into Logisim, and that's when things started to flow. So I think I got a good probably 80% of it. I think I got the carry out pretty good.
Yeah.
So I'm gonna save that. I'm definitely keeping this because this did seem to help, because out of all the schematics and all the crap I was looking at online, um, nothing really truly like helped or held my hand in a way. Just the math all pointed in the right direction, but nothing ever showed me truly how to go from like 50 transistors to 16 or 27 transistors to 16. I couldn't find anything that actually truly was like, here's an easy way to figure it out. This stuff talks about that. product of sums and all that stuff. Like here was this shows minimized, and I'm like, well, this ought to do it. And you see here the C out. There's a way to minimize the stuff, but the C out was just, I don't know. It was really weird on how I figured out there's something here that I'm missing that was able to get us from 15 transistors, the two AND gates, and the one OR gate into whatever this thing is. And I think it may be here, but this this alone didn't tell me. It just basically was like, hey, it was like a flag, like, look here, there's something here, but I don't know what it was. That, really when I did the matrix is really what I think it really showed. And maybe this thing here is a simpler way of doing this that I don't understand. So I'd like to figure this out and see if I can implement that in further designs so that I can do stuff like that quicker. Because it took me hours to work on this matrix and to really work out each individual trace. Um, so, and this thing too, like I was just, I don't know. I was trying to figure out again the inputs and the outputs. Um, but this stuff is not really as informative without the actual gates, because you don't know where you can send that one without shorting out, on a negative terminal, or vice versa. So there may be something even here too, but I'm not 100% on all this stuff. So, but I am glad to see that this is working. So who knows how far I can reduce it. But see, now you can take that guy, you can get rid of all this crap, and just have 4 of these guys. I might need to give myself some more room, huh? Because these are in clusters, aren't they? Yeah, I think. And that's all touching. That's not going to work. Yeah, I'm kind of wasting my time on that. But already looking like a much more efficient and actually looking like a chip, huh? This is looking pretty decent. And there's more I can do to continue. But I don't know if I'm going to keep working on that right now. I'd like to try and get a couple more hours of sleep before work. But yeah, I remember how horrible this one looked. And in fact, I still have the other one. Now let's exit out. Yeah, well, you guys can change your alarms on days that you don't have to go to school. Look at this. Just horrible.
I sometimes use words.
All right. Well, all right. So that's what I figured out. I'm glad it worked. Like I said, I got a little bit of help from a screenshot that I saw, but it's more important that I want to know the math and why I was able to reduce things the way I did. So I think one of the next things I want to learn is that product of sums stuff. I think that probably would have saved me a lot of time trying to reduce all these things. I think this here is what I figured out in that matrix on Google Sheets. I think that's what this is. So once I can figure this out, then it'd be another thing that I learn, and it'd be another step in the right direction of making these chips, making this stuff work pretty good. So I think I did things obviously the hard way, but I haven't done this before. So it is what it is. But at least it works. We're making good progress. So we'll see what I learn about all that, and see what I figure out. But the next step is now these circuits are going to be a little bit more streamlined already. So, but I'll probably work on condensing that the full bet adder first, get it a little bit better, a little bit more efficient, and then we'll finish off this chip and actually can play the game. But you'll see how it is important that you make advanced chips that are really good, because otherwise you're making these big monstrosities that are horribly slow that it's not it's going to continue to be even worse and worse and worse as you go. So all right, that's what we got.